Somewhere in the fabric of the universe, there may exist a doorway that does not lead forward or backward, but times through asterisk. Not a door made of matter, not something you could touch or see, but a hidden connection written into the geometry of space itself. A passage that links distant regions of the cosmos, as if distance were never meant to matter. This idea sounds like imagination, yet it was born not from science fiction, but from mathematics, quiet equations that suggested space might be capable of folding in on itself. To the brain, space feels vast, continuous, and absolute. Light takes years to cross it. Objects remain separated by impossible distances. And yet, the laws of physics do not insist that space must remain stretched and flat. Under extreme conditions, space can bend, curve, and distort. If it can bend far enough, it may touch itself. And where space touches space, a doorway may appear. A shortcut the universe never promised, but never fully denied. This is the idea behind a wormhole, not a tunnel carved through space, but a connection formed times by times space. A bridge between two distant points, held together not by walls, but by gravity and geometry. In theory, such a door could make vast distances meaningless. In practice, it raises questions that reach far beyond travel questions about time, causality, and the limits of reality itself. Because if space can be connected in this way, then time may follow. Entering such a doorway might not only take you elsewhere, but times elsewhere asterisk. The universe, carefully ordered by cause and effect, would have to tolerate loops, contradictions, and paradoxes. And nature does not allow such disruptions easily. So tonight, we will not imagine wormholes as gateways to adventure, but as quiet problems hidden in the equations of the universe. We will explore why physics allows them to exist, why reality resists them, and what it would truly mean if such a door could ever remain open. Slowly, gently, one idea at a time. Because some doors in space are not meant to be rushed toward, but carefully understood. A wormhole is not a tunnel carved through space, nor a hole punched into the universe, but a consequence of how space itself may be allowed to behave under extreme conditions. In modern physics, space is not an empty container where objects float independently of one another. It is a dynamic structure that can bend, stretch, twist, and fold in response to mass and energy. According to Einstein's general theory of relativity, gravity is not a force pulling objects together, but a curvature in space-time itself, shaped by the presence of matter. When this curvature becomes extreme enough, the geometry of space can behave in ways that defy everyday intuition. A wormhole, in its most precise definition, is a mathematical solution in which space-time curves so intensely that two distant regions become directly connected, forming a bridge that bypasses the space between them rather than crossing it. From the inside, this connection would not feel like traveling across vast distances. It would feel like stepping through a doorway where distance collapses into near nothingness. What makes wormholes so unsettling is that they emerge naturally from the equations of relativity without requiring exotic assumptions at first glance. When physicists explore solutions to Einstein's equations under extreme gravitational conditions, they find geometries where space-time folds back onto itself, creating structures known as Einstein-Rosen bridges. These bridges do not violate known laws outright. They simply exist at the edge of what those laws allow. In these models, space behaves less like a flat surface and more like a flexible fabric capable of connecting distant points through curvature alone. The universe, according to mathematics, does not forbid such shortcuts, it merely makes them extraordinarily difficult to sustain. A crucial detail often misunderstood is that wormholes are not holes times in time-space, but rearrangements times of time-space. Nothing is removed, nothing is torn. Instead, the distance between 2 points is reduced by bending the geometry between them. Imagine space not as a straight line, but as a folded sheet where 2 distant points touch. The wormhole is the fold, not the gap. This distinction matters because it reveals why wormholes are so fragile. The same gravitational forces that create them also threaten to destroy them. Without precise conditions, the bridge collapses instantly, sealing itself before anything can pass through. Another unsettling implication is that wormholes do not merely connect places, they connect frames of reference. If space-time itself is being bent and reconnected, then time is inevitably involved. The equations do not separate space from time, they bind them together. Any structure that rearranges space must also rearrange temporal relationships. This is why wormholes immediately raise questions about time travel, causality, and paradox. The universe appears deeply uncomfortable with anything that allows effects to precede causes, and wormholes sit dangerously close to that boundary. From a physical standpoint, no confirmed wormhole has ever been observed. Their existence remains theoretical, constrained by mathematics rather than evidence. Yet their persistence in our equations is telling. Physics has a history of mathematical structures appearing long before they are observed, sometimes decades earlier. Wormholes occupy that same uneasy category solutions that refuse to disappear, even when reality seems unwilling to accommodate them. They exist not as fantasy, but as unresolved possibilities, lingering in the deep structure of space-time. So when we ask what a wormhole really is, the most honest answer is this: it is not a doorway waiting to be opened, but a question the universe has not fully answered. A suggestion embedded in the geometry of reality itself, hinting that space may be far less rigid, far more connected, and far more strange than it appears from the calm surface of everyday experience. The idea of a wormhole does not come from imagination, but from a quiet consequence hidden deep within Einstein's equations, where gravity and geometry become indistinguishable. In general relativity, space-time is described as a four-dimensional fabric whose curvature determines how matter moves and how time flows. And when physicists first solved these equations for extreme gravitational scenarios, they discovered something unexpected. The mathematics allowed space-time to connect distant regions directly, forming what appeared to be a shortcut through the universe. This solution, known as the Einstein-Rosen Bridge, emerged naturally when describing black holes, suggesting that beneath the surface of intense gravity, space-time could form a throat-like structure linking two separate points. Importantly, this bridge was not designed to enable travel. It was simply what the equations produced when pushed to their limits. Einstein himself viewed it as a mathematical curiosity rather than a physical passage, a fragile structure that would collapse too quickly to be useful. Yet its existence revealed something profound: that space-time, under sufficient curvature, is not constrained to behave linearly. Distance, which feels absolute in everyday experience, becomes flexible when geometry dominates. The universe, according to relativity, does not measure separation by meters or light years alone, but by the shape of space-time itself. If that shape allows two distant points to touch, then distance loses its meaning. This realization quietly unsettles one of our deepest assumptions, that space must be crossed to be traversed. Instead, Einstein's equations suggest that space can be rearranged, folded, and reconnected, creating pathways that do not violate motion but redefine it. Wormholes, in this sense, are not violations of physics, but extreme expressions of it, hidden shortcuts that exist not because the universe wants them, but because its fundamental structure cannot entirely prevent them. Einstein's shortcut is not a fantasy route drawn onto the universe from the outside. It is a possibility that appears from within the mathematics of space-time itself. In general relativity, gravity is not an invisible force acting across distance, but the shape of space-time curvature that tells matter how to move and tells time how to flow. When that curvature becomes extreme, geometry begins to behave in ways that feel almost impossible from the perspective of everyday life. Space, which seems like an endless separation, becomes something elastic, capable of bending so deeply that two distant regions can be brought into direct connection, as if the universe had quietly folded its own map. The first strong hint of this comes from what are called Einstein-Rosen bridges, solutions that arise when physicists explore the geometry surrounding black holes. In the simplest view, these bridges look like a throat linking two separate regions of space-time. The strange part is that the equations do not introduce this throat as a special feature designed for travel. It emerges naturally as a consequence of describing extreme curvature. That is what makes the idea so haunting. The universe is not being asked to create a shortcut, it is simply being described accurately, and the shortcut appears as a byproduct of that description. But this bridge is not a friendly corridor waiting to be used. In the original Einstein-Rosen picture, the connection is unstable, collapsing too quickly for anything to pass through. It pinches shut almost immediately, like a doorway that exists for an instant and then disappears before a traveler could reach it. In a sense, relativity reveals the possibility and then takes it away in the same breath. The geometry can connect distant points, yes, but the dynamics of space-time do not easily allow that connection to remain open. The shortcut is permitted by structure, but resisted by stability. What's crucial to understand is that this is not about drilling through space, or punching holes, or tearing reality. A wormhole, in the relativistic sense, is a rearrangement of distance. It is what happens when the metric, the mathematical object that defines lengths and times, changes in such a way that the shortest path between 2 points no longer resembles a straight line through ordinary space. The universe does not need to move objects faster than light to make far places feel near. It only needs to reshape the geometry so that near and far are redefined at the level of space-time itself. This is why wormholes are sometimes described as hidden shortcuts. They are not violations of motion, but violations of intuition. They challenge the assumption that distance is something you must pay for with time. In curved space-time, distance is negotiable, but the negotiation is done through gravity and geometry, not through engines and speed. Einstein's equations quietly suggest that the universe may contain configurations where space can be connected like folded paper, even if those configurations are rare, unstable, or unreachable. The mathematics does not promise that nature uses them, but it refuses to remove them completely. And so the door in space becomes a precise kind of metaphor, not a literal door with hinges, but a transient connection that appears when space-time is pushed to its limits. Einstein's hidden shortcut exists as an implication of the deepest description we have of gravity, and that implication lingers like a question the universe has not fully answered. If such shortcuts can exist even briefly in theory, what does that say about the true shape of reality, about how space is stitched together, how distance is defined, and how much of the cosmos is connected in ways we have not yet learned to see? What makes wormholes so compelling is not that physics embraces them, but that physics almost does. When the equations of general relativity are examined carefully, nothing explicitly forbids space-time from forming these deep connections. The geometry allows it. The mathematics supports it. And yet, when physicists attempt to translate these solutions into something that could exist in the real universe, resistance appears everywhere. The laws of physics seem to tolerate wormholes only at the edge of possibility, permitting their shapes but denying their endurance. It is as if reality acknowledges the idea but refuses to let it settle. The central obstacle is gravity itself. The same curvature that creates a wormhole also tries to destroy it. Under normal conditions, gravity is attractive. It pulls matter inward, tightening space-time rather than holding it open. In a wormhole, this attraction becomes catastrophic. The throat of the connection collapses faster than light could cross it, sealing the passage almost instantly. From the outside, the wormhole never truly opens. From the inside, it pinches shut before existence has time to register it. The geometry allows the connection, but the dynamics crush it. To keep a wormhole open, physics demands something profoundly unusual, a form of matter or energy that behaves opposite to everything we know. Instead of attracting, it would need to repel. Instead of adding weight to space-time, it would need to reduce it. This hypothetical requirement is often described as exotic matter, not because it is mysterious, but because it violates the energy conditions that normally govern the universe. These conditions are the quiet rules that say energy should be positive, gravity should pull inward, and space-time should behave sensibly. A stable wormhole would require breaking those rules gently but persistently. Here is where reality grows cautious. While quantum physics does allow fleeting violations of these energy conditions on microscopic scales, such effects are tiny and temporary. They appear and vanish in fractions of a second, far too weak to support a macroscopic structure like a wormhole. The universe seems willing to bend its rules briefly, but not long enough to hold open a door across space. Every attempt to scale these effects upward runs into instability, collapse, or contradiction. Physics permits just enough strangeness to tease the idea, but not enough to sustain it. There is also a deeper reason for this resistance. Wormholes threaten causality, the principle that causes must precede effects. A stable wormhole could, in theory, connect different moments in time as well as different places in space. This would allow information to loop back on itself, creating paradoxes that unravel the logical structure of reality. Many physicists suspect that the universe has built-in safeguards against such outcomes. These safeguards do not appear as explicit laws, but as patterns of instability that prevent dangerous configurations from lasting. Wormholes may be casualties of this deeper self-protection. So when we say physics almost allows wormholes, we mean something precise. The equations open the door just wide enough to reveal what might be possible, then quietly push it closed again. The universe seems to flirt with the idea of shortcuts through space-time, only to withdraw before they can become real. This tension between permission and prohibition is what keeps wormholes alive in theory and absent in observation. They exist not as objects we can build or find, but as boundary markers, showing us exactly where our understanding of space, time, and reality begins to strain. The most revealing question about wormholes is not whether they can exist, but why they refuse to remain. Again and again, when physics is pushed to its limits, space-time seems willing to form a connection only to destroy it almost immediately. This refusal is not dramatic. There is no explosion, no cosmic warning. The geometry simply collapses under its own rules. The universe allows the idea of a door in space, but it does not allow the door to stay unlocked. At the heart of this refusal is stability. Space-time, like any physical system, prefers configurations that minimize tension and imbalance. A wormhole represents an extreme imbalance, a region where curvature is stretched unnaturally, held open against the inward pull of gravity. Every part of the throat experiences enormous pressure to close, to return space-time to a smoother, less distorted shape. Without constant support, the geometry snaps back, erasing the shortcut before anything meaningful can pass through. The universe behaves as though smoothness is safer than connection. Even when physicists imagine supplying the required exotic energy to counteract this collapse, new problems emerge. Quantum effects begin to amplify. Tiny fluctuations grow unstable. The very act of trying to stabilize the wormhole introduces disturbances that tear it apart. Instead of a doorway, the result becomes a region of violent unpredictability. The more one tries to force the wormhole to remain open, the more the laws of physics respond with resistance. Stability, not possibility, becomes the limiting factor. There is also a deeper layer to this resistance, one that goes beyond mechanics and enters principle. A stable wormhole would undermine the causal structure of the universe. It would allow signals to bypass normal paths, potentially arriving before they were sent. This is not just inconvenient, it threatens the logical order that physics relies on. Many researchers suspect that space-time contains a built-in censorship, a tendency to eliminate structures that would allow paradoxes to persist. Wormholes may collapse not because they are impossible, but because they are time's too disruptive asterisk. From this perspective, the instability of wormholes looks less like a flaw and more like a feature. The universe may tolerate extreme curvature only briefly, using instability as a form of regulation. Any configuration that risks breaking causality is allowed to appear in theory, but not to endure in reality. The door can exist, but only as a moment, not as a passage. Nature seems to permit glimpses of forbidden geometry while preventing access to its consequences. So wormholes remain suspended in a strange state between permission and denial. The equations open the door, the dynamics close it. What remains is not a pathway to travel, but a boundary in understanding, a reminder that the universe is not only governed by what is mathematically possible, but by what is physically sustainable. Wormholes refuse to stay open not because they are nonsense, but because the universe appears to value coherence over shortcuts, and in that refusal, space-time quietly reveals its priorities. The moment a wormhole is taken seriously as a physical object, time enters the conversation whether we invite it or not. In relativity, Space and time are not separate stages where events play out independently. They are woven together into a single structure. Any distortion of space is automatically a distortion of time. This is why wormholes are never just shortcuts through distance. They are potential shortcuts through sequence itself. A connection that links two distant regions of space-time does not merely ask times where times you might arrive, but times when asterisk. And that question unsettles the deepest assumptions physics relies on. Causality, the principle that causes precede effects, is the quiet backbone of reality. Every prediction, every equation, every experiment assumes that the universe moves forward in a consistent order. Wormholes threaten this order not by breaking it outright, but by bending it. If one end of a wormhole experiences time differently than the other, which relativity allows under certain conditions, then the connection between them could link different moments rather than different places. A signal entering one side might emerge before it was sent. The universe would be forced to tolerate loops in cause and effect, where outcomes influence their own origins. These loops are not just philosophical curiosities, they are structural contradictions. A paradox does not merely confuse the mind, it destabilizes the logic that keeps physical law coherent. If information can arrive before it exists, then the equations governing its behavior lose their grounding. Physics becomes unable to define what is allowed because the timeline itself no longer has a clear direction. This is why wormholes immediately collide with questions that feel more metaphysical than mechanical. They do not just challenge engineering limits, they challenge the idea that reality unfolds in an orderly way. Some physicists have proposed that the universe resolves these contradictions automatically, not by forbidding wormholes outright, but by preventing any configuration that would allow paradoxes to become real. In this view, space-time contains a kind of self-correcting mechanism. Structures that threaten causality are permitted to appear briefly in theory, but they are destabilized before they can be used. Instability becomes a form of protection. The universe does not argue with paradox, it dissolves the conditions that would allow it. This idea is sometimes described as a chronology protection principle, not a law written explicitly into equations, but an emergent behavior of space-time itself. Whenever geometry begins to arrange itself in a way that would allow time to fold back on itself, quantum effects intensify, energy requirements explode, and the structure collapses. The door in space does not just close, it was never meant to be crossed. Time, it seems, is guarded more carefully than distance. What makes this so compelling is that it suggests a hierarchy of priorities within the universe. Space may be flexible, distance may be negotiable, but sequence cause leading to effect appears sacred. Wormholes threaten to blur that sequence, and in response, reality tightens its grip. The refusal of wormholes to remain open may not be about energy or matter alone, but about preserving the arrow of time itself. The universe may allow us to imagine shortcuts through space, but it draws a firm boundary around the flow of events. So, when we consider wormholes, we are not just asking whether travel is possible. We are asking whether the universe would tolerate a reality where the future could reach back and touch the past. And every indication so far suggests that this is a door space-time is unwilling to leave open, not because it cannot be opened, but because what lies beyond would unravel the order that makes existence intelligible at all. When physics confronts the possibility of paradox, it does not respond with prohibition, so much as with resistance. The equations do not shout times no asterisk, they whisper times unstable asterisk. This is the essence of what many physicists call chronology protection, a tendency of space-time to prevent situations in which cause and effect could be reversed, not by decree, but by consequence. As geometries approach configurations that would allow time to loop, the mathematics begins to misbehave. Energy requirements spike, fluctuations amplify, what looked smooth becomes violently sensitive. The closer a system gets to enabling paradox, the more reality pushes back, as if instability were the universe's preferred method of enforcement. This resistance appears first at the quantum level. Near a would-be time loop, vacuum fluctuations, normally tiny and fleeting, are predicted to grow without bound. Particles pop into existence and fail to cancel out. Energy densities rise where none should accumulate. The very emptiness of space becomes restless. These effects are not decorative details. They are fatal to structure. Any wormhole arrangement that threatens chronology becomes a breeding ground for runaway processes that tear coherence apart. In this way, quantum physics does not forbid time travel explicitly. It renders it uninhabitable. What is striking is how local these defenses seem to be. The universe does not need to police all of space-time. It only needs to destabilize the region where causality would break. Like a fault line that slips under pressure, space-time releases stress by collapsing the configuration that caused it. The result is not a dramatic cosmic event, but a quiet erasure. The door forms, the pressure builds, the door dissolves. No traveler is needed, no violation occurs. Chronology is preserved by never being challenged long enough to fail. This suggests a deeper design principle, whether emergent or fundamental, that time is not merely another dimension to be rearranged at will, but a structural constraint that governs what configurations are allowed to persist. Space can curve dramatically and remain stable. Time cannot. The arrow of time events unfolding in a consistent order appears woven into the fabric more tightly than distance or orientation. Wormholes threaten to loosen that weave, and in response, the fabric tightens elsewhere, sacrificing the shortcut to preserve the sequence. Importantly, this protection does not require intelligence or intent. There is no cosmic guardian deciding what is permissible. The safeguards arise naturally from the interaction of relativity and quantum mechanics. When geometry strains against causality, quantum effects surge. When quantum effects surge, classical structures fail. The universe remains internally consistent without needing to be externally governed. Chronology protection is not a rule imposed on reality. It is a behavior that emerges when reality is pushed too far. This framing changes how we think about wormholes. They are not simply absent because we lack the technology to find them. They may be absent because any configuration that would make them useful triggers the very processes that destroy them. The universe allows us to write the equations, to imagine the door, to understand the geometry, but it refuses to let the story continue to the point of contradiction. In this sense, wormholes become a lesson rather than a pathway, revealing not just what space-time can do, but what it chooses not to sustain. And so the door in space remains guarded, not by locks or barriers, but by instability itself. The closer we approach a universe where effects outrun causes, the more violently the mathematics reacts. Chronology is preserved not through prohibition, but through collapse. The safeguard is subtle, pervasive, and relentless, ensuring that while we may glimpse the possibility of shortcuts through reality, we cannot remain within them long enough to undo the order that makes reality intelligible. One of the most unsettling consequences of wormholes is not where they might lead, but how they challenge the very idea of time as a one-way flow. In everyday experience, time feels directional. Moments move forward, causes come before effects, memory points backward while expectation points ahead. This directionality feels so fundamental that it is rarely questioned. Yet in the equations of relativity, time does not inherently prefer a direction. It is treated as another dimension different in character, but not protected from rearrangement. Wormholes expose this quiet vulnerability. If space-time can be bent enough to connect distant places, it can also blur the distinction between earlier and later. In a universe with a traversable wormhole, time could lose its role as a guide. Events would no longer be ordered solely by sequence, but by geometry. Two moments separated by years could become neighbors, not because time reversed, but because the structure connecting them ignored duration altogether. From the outside, the universe might still appear to move forward normally, but locally, near the wormhole, the concept of before and after would begin to lose clarity. The brain struggles to imagine this because consciousness itself is built on sequence. Thought unfolds in time. Meaning depends on order. Wormholes threaten to loosen that foundation. This is where the discomfort deepens. Physics relies on predictability. If time ceases to behave as a consistent parameter, prediction collapses. The equations no longer know which boundary conditions apply because boundaries themselves become ambiguous. An effect could influence its own cause not through magic, but through geometry. This is not merely strange, it is destabilizing. A universe where time stops being a direction is a universe where explanation becomes circular. Wormholes do not just challenge travel, they challenge understanding. Some physicists argue that the universe avoids this outcome by making such configurations inaccessible. Time, in this view, is not defended by law, but by practicality. Any attempt to erase its direction introduces instabilities that overwhelm the system. Energy diverges, fluctuations explode, the structure fails before time can lose its arrow. The universe seems to insist that while space may fold, time must still flow. The arrow may wobble, but it cannot be erased. There is also a deeper philosophical implication. If time were no longer directional, identity itself would fracture. Memory would no longer anchor the self. Choice would lose meaning if outcomes could precede decisions. Responsibility, causation, and continuity would dissolve into ambiguity. Wormholes bring these questions out of abstraction and into physics. They suggest that the arrow of time is not just a feature of experience, but a requirement for coherence at every level, from particles to thought. So when we imagine a door in space, we must also imagine a distortion in time. And when we imagine that distortion lasting, we are forced to confront a universe that no longer tells a story in sequence. Everything we know resists that outcome. The mathematics strains, the physics destabilizes, the universe pulls back. Time remains a direction not because it must, but because without direction, nothing else can remain intact. In this sense, wormholes act like mirrors held up to reality. They reveal how close physics can come to erasing time's arrow and how firmly the universe resists crossing that boundary. The door may exist in theory, but it opens onto a region where time itself begins to lose meaning. And that may be precisely why the universe never allows us to step through. When all the implications of wormholes are gathered together, distorted space, unstable geometry, broken causality, and the erosion of time's direction, a single pattern begins to emerge. The universe appears deeply invested in preserving order. Not order as rigidity, but order as coherence. The laws of physics do not merely describe what can happen, they quietly enforce what must continue to make sense. Wormholes threaten that sense, not because they are exotic, but because they allow too much freedom. Freedom for effects to outrun causes, freedom for geometry to override sequence, freedom for reality to contradict itself. This is why the resistance to wormholes feels systemic rather than local. It is not just gravity collapsing a throat or quantum fluctuations destabilizing a region. It is the entire framework of physical law responding to a configuration that would undermine its own logic. Whenever space-time begins to arrange itself in a way that would erase temporal order, multiple mechanisms activate simultaneously: instability, divergence, collapse. No single rule forbids the door. Instead, every rule makes standing in the doorway impossible. The universe does not lock the door, it makes the room behind it uninhabitable. What emerges from this is a picture of reality that is flexible but not permissive. Space may bend, distance may be reshaped, even time may slow or stretch. But the universe draws a quiet boundary around reversibility. It allows complexity, but not contradiction. Wormholes press directly against that boundary. They are geometrically elegant and mathematically allowed, yet physically unsustainable. Their failure is not accidental, it is structural. The order of events is protected not because it is sacred, but because without it, structure itself dissolves. This protection also explains why wormholes remain so compelling. They reveal where physics transitions from description to defense. At small scales, quantum mechanics tolerates uncertainty. At large scales, relativity tolerates curvature. But at the intersection where geometry threatens chronology, the tolerance ends. The universe seems to say, space may be rearranged, but meaning must remain sequential. Without sequence, there can be no prediction, no memory, no persistence. Reality becomes noise. Seen this way, wormholes are not failed inventions. They are boundary markers. They show us how far space-time can be pushed before coherence collapses. They expose the hidden priorities of the universe. Not speed, not shortcuts, but continuity. The flow from cause to effect is not just a habit of experience, it is a stabilizing principle embedded in the fabric of existence. Wormholes violate nothing explicitly, yet they violate everything implicitly. So the door in space remains a suggestion rather than a passage. It exists in equations, in thought, in possibility, but not in persistence. The universe allows us to glimpse the idea of absolute connection, then withdraws before that idea can erase order. And in that withdrawal, something profound is revealed. Reality is not built to be traversed in every way imaginable. It is built to endure, and endurance requires sequence. With this, the problem of paradox comes to rest, not solved but contained. The universe does not explain why it protects its order. It simply does. And wormholes, poised eternally between allowance and collapse, remind us that some doors exist not to be opened, but to show us where the structure of reality holds firm. The question of stability is where imagination finally collides with the universe's patience. Physics does not immediately dismiss the idea of a stable wormhole. Instead, it asks a quieter, more difficult question. Asterisk, under what conditions could space-time hold such a structure open without tearing itself apart? Asterisk, in theory, stability is not forbidden. The equations allow configurations where a wormhole throat does not instantly collapse. But these configurations exist in a narrow, fragile balance, like a structure balanced perfectly on a point, sensitive to the smallest disturbance. Stability, in this context, is not a natural state. It must be maintained continuously against the preferences of space-time itself. To achieve this balance, space-time would need to be supported by something unlike ordinary matter. Normal matter has positive energy density and attractive gravity. It pulls space-time inward, tightening curvature and encouraging collapse. A stable wormhole requires the opposite behavior, negative energy density, a form of stress that pushes outward, counteracting gravitational collapse and holding the throat open. This requirement is not speculative. It emerges directly from the mathematics. Without this repulsive contribution, the geometry cannot remain open long enough to be meaningful. The door in space demands a force that nature does not readily provide. Quantum physics does offer a glimpse of such behavior, but only fleetingly. In certain quantum processes, negative energy densities can appear briefly, flickering into existence before vanishing again. These effects are real, measurable, and deeply strange, but they are also extremely small and tightly constrained. The universe allows them only in short bursts, over microscopic distances, as if carefully rationing how much structural imbalance it will tolerate. Scaling these effects up to macroscopic sizes large enough to support a wormhole pushes against limits that quantum theory itself enforces. The more one tries to extend negative energy, the more violently the system resists. Even if such exotic support could exist, stability would remain precarious. A stable wormhole would not simply sit passively in space-time. It would interact with everything around it: radiation, particles, gravitational waves, even the passage of time itself. Each interaction would introduce fluctuations, stresses, and asymmetries that threaten collapse. Maintaining stability would require constant correction, perfect symmetry, and isolation from disturbance. In a universe filled with motion, noise, and change, such conditions are extraordinarily unlikely to persist. There is also a deeper concern hidden beneath the technical challenges. Stability is not just about geometry, it is about consequence. A stable wormhole would reopen the door to paradox. If the throat remained open long enough, differences in gravitational time dilation between its ends could turn it into a time machine. The universe seems particularly hostile to this outcome. Many physicists suspect that even if stability were achieved momentarily, new instabilities would emerge precisely to prevent temporal contradiction. Stability, in this sense, is not merely difficult, it may be self-defeating. So when we ask whether a wormhole could ever be stable, the most honest answer is that stability is allowed only in theory, not in habit. The universe tolerates the idea as a boundary case, a mathematical possibility that sharpens our understanding of space-time's limits. But every attempt to anchor that possibility in reality encounters resistance layered upon resistance. Gravity pulls inward, quantum rules constrain outward pressure, causality demands protection. Stability is squeezed from all sides. In this light, wormholes appear less like unfinished technology and more like thought experiments written into reality itself. They show us how space-time behaves when pushed to its extremes and where it begins to defend its own coherence. A stable wormhole is not impossible in principle, but it is incompatible with the way the universe prefers to exist. The door in space may be drawn in the equations, but the ground beneath it never stops shifting, ensuring that it can never remain open long enough to be crossed. At the center of the stability problem lies a requirement that feels almost deliberately unreachable. To keep a wormhole open, space-time must be supported by something that behaves unlike any familiar substance in the universe. Ordinary matter, everything from stars to atoms, has positive energy and attractive gravity. It deepens curvature, pulling space-time inward. A wormhole, however, demands the opposite. Its throat must be propped open by negative energy, a form of stress that pushes outward against gravity's collapse. This is not an optional feature or a speculative add-on. It is a mathematical necessity. Without exotic matter, the geometry cannot hold. Negative energy is not pure fiction. Quantum physics allows it in very specific, tightly controlled situations. In the quantum vacuum, energy can dip below zero for extremely brief moments, producing effects such as the Casimir force. These phenomena demonstrate that negative energy densities are not forbidden outright, but they are constrained with extraordinary precision. The universe allows them only as fleeting fluctuations, confined in time and space, balanced carefully so that no large-scale violation accumulates. Exotic matter exists only on a leash, and that leash is short. The difficulty arises when scale enters the picture. A traversable wormhole would require vast quantities of negative energy, sustained over macroscopic distances and extended durations. Every attempt to imagine this runs into quantum inequalities, rules that limit how negative energy can be, how long it can last, and where it can appear. The more negative energy one tries to concentrate, the more severe the compensating effects become elsewhere. Nature seems to demand repayment, as if borrowing from stability always comes with interest. The universe tolerates imbalance only briefly and only locally. Even if one could somehow assemble enough exotic matter, a deeper instability remains. Negative energy does not simply sit quietly in space-time. It interacts violently with surrounding fields. Tiny disturbances can grow uncontrollably. Radiation passing through the wormhole could amplify fluctuations, destabilizing the throat. Instead of a stable doorway, the result might be a region of extreme turbulence, where geometry oscillates wildly before collapsing. The very ingredient needed to hold the wormhole open also makes it fragile beyond practicality. There is also a conceptual unease embedded in exotic matter itself. Negative energy challenges the intuitive notion that energy should ground reality, not undermine it. Many of the energy conditions violated by exotic matter are not arbitrary assumptions. They are woven into the consistency of classical physics. Breaking them too freely risks opening the door not just to wormholes, but to runaway instabilities that would render space-time unpredictable. Exotic matter does not simply support a shortcut, It threatens to erode the rules that keep structure intact. Because of this, some physicists suspect that exotic matter is not merely rare, but fundamentally constrained to irrelevance at large scales. The universe may allow it only as a mathematical whisper, never as a physical resource. Wormholes would then remain theoretical constructs permitted by equations, but starved of the material they need to exist. The door is drawn, the hinges are specified, but the material required to hold it together never arrives. So the problem of exotic matter becomes the universe's quiet veto. Not an explicit prohibition, but a practical impossibility. Wormholes demand a substance that reality seems unwilling to supply in usable form. And in that refusal, space-time protects itself once again, not through force, but through scarcity. The door in space may be mathematically consistent, but without exotic matter, it has nothing to stand on. Even if exotic matter could somehow be gathered, shaped, and sustained, stability would remain in direct conflict with the nature of reality itself. A stable wormhole is not a static object resting quietly in space-time. It is a dynamic structure embedded in a universe that never stops moving. Radiation streams through space. Gravitational waves ripple constantly. Particles appear and vanish. Time flows unevenly under gravity. A wormhole would be forced to respond to all of this activity simultaneously. Every interaction, no matter how small, would disturb its delicate balance. Stability would not simply be difficult, it would need to be continuously defended against the universe's own restlessness. This is where theory begins to strain. Stability demands perfect symmetry, constant regulation, and isolation from disturbance. Reality offers none of these. Even black holes, which are among the most stable objects known, are shaped by accretion, radiation, and interaction. A wormhole, far more delicate than a black hole, would need conditions more controlled than anything naturally produced in the cosmos. The slightest imbalance between its two ends, differences in mass, radiation, or gravitational environment, would introduce stresses that propagate through the throat, amplifying rather than settling. What begins as a tiny fluctuation becomes a fatal instability. Time itself becomes a destabilizing force. If the two ends of a wormhole experience different gravitational fields, time flows at different rates on each side. This difference accumulates relentlessly. Over time, the wormhole would no longer connect the same moment at both ends. The geometry would twist under temporal strain, transforming the structure into something increasingly unstable. The longer the wormhole exists, the more distorted its internal relationship with time becomes. Stability, paradoxically, makes collapse more likely. There is also an unavoidable feedback loop between observation and existence. Any attempt to use a wormhole to send matter, energy, or even information through it adds stress to the system. The act of traversal is not neutral. It injects mass energy into a geometry already struggling to remain open. Each interaction increases curvature, intensifies fluctuations, and accelerates collapse. A wormhole that cannot be used without destroying itself is stable only in the most trivial sense. It may exist briefly, but it cannot function. From this perspective, stability becomes a contradiction in terms. A wormhole that remains perfectly isolated and untouched might avoid immediate collapse, but it would also be meaningless. The moment it becomes relevant, observable, usable, or connected, it destabilizes. The universe appears to allow wormholes only as idealized limits, not as physical tools. They exist at the edge of theory, not within the flow of experience. This conflict between stability and reality reveals something essential about spacetime's priorities. Reality does not favor fragile configurations, no matter how elegant they appear mathematically. Structures that require constant perfection to survive are eliminated by the smallest imperfection. Wormholes sit precisely in this category. They demand too much control, too much symmetry, too much silence from a universe that is fundamentally noisy. And so stability remains theoretical, while reality continues uninterrupted. In the end, the question is not whether a wormhole could times be stable in an abstract sense, but whether stability itself is compatible with a living universe. All evidence suggests it is not. The door in space may be definable, imaginable, and mathematically precise, but reality, in all its motion and imbalance, refuses to hold it open. At this point, the question of stability begins to shift. After following the physics to its limits, it becomes clear that asking whether a wormhole can remain stable may already assume too much. Stability is a concept borrowed from ordinary objects, bridges, buildings, orbits, things that exist comfortably within space-time. A wormhole is not one of these. It is not an object placed into the universe. It is a rearrangement of the universe itself. Expecting space-time to hold such a configuration steady may be like expecting the surface of the ocean to freeze into a permanent wave. The question itself may misunderstand the nature of what is being asked. Wormholes emerge in theory as transitional geometries, not resting states. They appear at the boundaries where space-time is pushed beyond its usual behavior, where curvature becomes extreme and definitions begin to blur. In this regime, permanence is not the goal. Change is. The equations describe possibilities, not destinations. A wormhole, in this sense, is more like a momentary alignment than a structure, an instant where geometry briefly allows connection before reasserting separation. Stability is not denied, it is irrelevant. This reframing alters how we interpret the universe's resistance. Space-time may not be failing to support wormholes. It may be doing exactly what it is designed to do: resolve extreme configurations back into coherence. From this perspective, collapse is not a flaw, but a return. The universe does not punish wormholes, it absorbs them. Geometry relaxes, distortion smooths out, the shortcut dissolves into continuity. Stability would imply a refusal to heal, a willingness to remain strained indefinitely. Reality shows no such tendency. There is also an informational dimension to this idea. A stable wormhole would preserve a specific arrangement of space-time against entropy. It would maintain order in a configuration that is extraordinarily precise. But the universe consistently favors dispersion over preservation. Entropy increases, gradients flatten, distinctions blur. Wormholes, requiring exact alignment across vast distances and times, stand in opposition to this trend. Their instability may simply reflect the universe's deeper commitment to forgetting rather than remembering, to smoothing rather than maintaining sharp connections. Seen this way, wormholes become messages rather than mechanisms. They tell us something about the flexibility of space-time, but also about its preferences. Space can bend, but it does not like to stay bent. Time can stretch, but it resists looping. Connections can form, but they do not persist without cost. The universe allows glimpses of radical geometry without allowing it to settle into permanence. Wormholes mark the edge of that allowance. So the failure of stability does not close the discussion, it completes it. Wormholes show us how space-time behaves when asked to do too much, to connect too far, to violate too deeply the assumptions that make continuity possible. The door in space appears only briefly, not because it is forbidden, but because it is transient by nature. Stability was never the promise. The lesson was, the moment you imagine entering a wormhole, physics stops being abstract and becomes intimate. This is no longer a question of equations on paper, but of what space-time would do to matter, perception, and identity itself. A wormhole is not an empty tunnel waiting calmly for a traveler. It is a region of extreme curvature, where the geometry of space and time is stretched to its limits. Entering such a region would mean placing your body, your atoms, and your sense of sequence into an environment where the usual rules no longer dominate. The universe would not welcome you gently. It would test whether you could exist at all. As you approached the throat of a wormhole, gravity would not behave like a simple pull. Instead, it would vary dramatically across your body. Different parts of you would experience different space-time conditions simultaneously. These tidal forces could stretch, compress, and distort matter in ways far beyond ordinary experience. In extreme cases, they would tear atoms apart before the journey even began. Survival would depend not on strength, but on delicacy, on whether the curvature could remain smooth enough, long enough, to avoid shredding structure into chaos. Even if the tidal forces were somehow gentle, perception itself would begin to unravel. Inside a wormhole, space would not extend in familiar directions. Forward motion would not feel like moving forward. Distance would lose its intuitive meaning. Your senses, evolved to navigate nearly flat space-time, would receive signals that contradict one another. Light could bend unpredictably. Orientation could dissolve. The brain depends on stable geometry to construct reality. Inside a wormhole, that stability disappears. You would not merely travel through space. You would travel through a region where space itself is confused. Time would add another layer of disorientation. Because space-time is unified, changes in geometry would alter how time flows across the wormhole. Your internal clock might not agree with the universe outside. Moments could stretch or compress. Cause and effect could feel misaligned. From your perspective, the journey might seem instantaneous, endless, or fragmented. From the outside, it might never appear to happen at all. Entering a wormhole would mean surrendering any guarantee that time remains coherent. There is also the question of what it means to times arrive asterisk. A wormhole does not promise a clean exit into a stable environment. The region on the other side could be violently curved, filled with radiation, or collapsing even as you approach it. The door in space does not open into safety by default. It opens into uncertainty. The universe offers no assurances that the destination is compatible with structure, life, or persistence. Passage does not imply survival. Perhaps the most unsettling consequence is that entering a wormhole may not feel like a journey at all. There may be no sense of motion, no passage, no story of travel. Geometry could collapse the experience into a single transition, erasing the narrative continuity that defines movement. You would not cross space, you would be times redefined by it, asterisk. And in that redefinition, the question shifts from where you would go to whether the concept of you could remain intact. This is why the idea of entering a wormhole remains so haunting. It is not simply dangerous in a mechanical sense. It threatens the assumptions that allow experience to exist as experience. To step into such a structure would be to place yourself inside a question space-time itself struggles to answer. The door in space does not lead somewhere else. It leads to the limits of what reality can hold together. Survival inside a wormhole would not depend on courage or technology alone, but on whether matter itself can tolerate the conditions imposed by extreme space-time curvature. Every object, including the human body, is held together by delicate balances of forces, electromagnetic bonds, nuclear interactions, quantum stability. A wormhole does not gently transport these balances. It subjects them to gradients so severe that the notion of structural integrity becomes uncertain. Even small variations in curvature across a short distance could overwhelm the forces binding atoms together. Survival would require space-time to remain extraordinarily smooth, a condition that contradicts the very processes that create wormholes in the first place. As the body encounters these conditions, the idea of stress takes on a new meaning. In ordinary environments, stress is distributed gradually. Inside a wormhole, space-time itself becomes uneven. One part of the body may experience stronger curvature than another, producing forces that pull in opposing directions simultaneously. This differential interaction is not something biology evolved to handle. Cells, tissues, and even molecules could be subjected to conflicting space-time instructions, as if reality were giving contradictory commands at once. The result would not be pain in any familiar sense, it would be disintegration. Even if the body were somehow protected from immediate destruction, consciousness would face its own limits. Awareness depends on continuity. Thought unfolds in sequence. Memory relies on order. Inside a wormhole, that order becomes unreliable. Signals traveling through the nervous system might experience different space-time conditions, arriving out of sync or distorted. The brain could no longer assemble a coherent model of experience. Perception might fragment into disconnected impressions, stripped of narrative or meaning. Survival, in this context, would not simply mean remaining alive, it would mean remaining times aware, asterisk. There is also the question of persistence. A wormhole is not a stable environment that one can occupy. It is a transient configuration, collapsing even as it forms. To survive inside, it would require existing within a structure that is actively trying to erase itself. The traveler would not be moving through space. They would be embedded in a process of collapse. Every moment inside the wormhole would be borrowed time, dependent on geometry that is losing coherence with each passing instant. From the outside, this collapse would likely appear instantaneous. The wormhole would form and vanish before any signal could confirm traversal. From the inside, if such a perspective could exist at all, experience might stretch or compress unpredictably. Survival would not be measured in seconds or distance, but in whether the structure allows continuity long enough for existence to remain defined. The universe offers no guarantee of such continuity. It does not promise a beginning, a middle, or an end. Ultimately, the limits of survival inside a wormhole reveal something deeper than physical danger. They expose how tightly life and consciousness are bound to the ordinary structure of space-time. We exist because space is smooth enough, time is ordered enough, and causality is stable enough to support persistence. Wormholes push all of these conditions toward failure. To survive them would require not just new technology, but a universe willing to suspend its own preferences. This is why entering a wormhole remains more than a risk, it is a challenge to existence itself. The door in space does not merely test whether something can pass through, it tests whether reality can remain reality while allowing passage at all. Even if survival were somehow possible, a deeper question would remain unresolved. Would continuity still exist in a meaningful sense? Identity is not a static object carried through space. It is a process sustained through time. Memory, perception, and self-awareness depend on uninterrupted sequences of cause and effect within the brain. A wormhole threatens this sequence at its foundation. If space-time inside the wormhole rearranges temporal order even slightly, then the chain that maintains identity could fracture. You might emerge intact in structure, yet altered in continuity, alive, but no longer the same unfolding self that entered. The brain does not merely store information, it relies on timing. Signals arrive in precise patterns, synapses fire in ordered cascades. Consciousness emerges from coordination across time as much as across space. Inside a wormhole, where geometry reshapes temporal relationships, that coordination could be disrupted without any obvious physical damage. Thought might continue, but without coherence. Memory might persist, but without sequence. Experience could fragment into isolated moments, unlinked and unresolvable. The self, which depends on narrative flow, might dissolve into disconnected impressions. Even if the wormhole preserved relative timing locally, the comparison between inside and outside would remain problematic. You might exit into a universe where far more time has passed, or far less. Relationships, histories, and contexts would be severed. Identity is not formed in isolation. It is embedded in continuity with the environment. To arrive elsewhere in time is to arrive stripped of that continuity. Survival without context raises the question of whether identity can persist when all reference points have shifted beyond recognition. There is also the unsettling possibility that passage through a wormhole does not preserve uniqueness. If space-time geometry allows paths that loop or overlap, then the distinction between one instance and another could blur. Physics does not guarantee that information passing through such a structure remains singular. Duplication, erasure, or recombination are not ruled out by intuition alone. The universe has strict rules about information conservation, but those rules are deeply entangled with causality. Wormholes strain that entanglement. What emerges may be consistent with physics, but alien to experience. From the outside, any of these outcomes would be indistinguishable. Observers would see either emergence or collapse, arrival or absence. From the inside, if inside remains a meaningful concept, experience could be profoundly altered without any clear boundary marking the change. Identity does not fail dramatically. It fades quietly when continuity is interrupted. The door in space does not promise transformation, it risks erasure without destruction. This is why the question of entering a wormhole is not merely about travel or survival. It is about what it means to persist as a self in a universe where sequence can be rearranged. The laws of physics may allow matter to pass, energy to flow, and geometry to connect. But whether they allow identity to remain whole is far less certain. The door in space may open onto another location, another time, but it may not open onto the same times you asterisk. When all of these limits are taken together, physical destruction, loss of coherence, collapse of identity, a final pattern begins to appear. It is not simply that wormholes are dangerous. It is that passage itself may be incompatible with the structure of reality. The universe does not merely make traversal difficult. It seems to dissolve the very conditions required for something to pass through times in a meaningful way. Survival, continuity, and identity are not add-ons to existence. They are prerequisites, and wormholes quietly remove each one, not through violence, but through incompatibility. What appears again and again is that wormholes exist most comfortably as empty geometries. As soon as matter, energy, or information attempts to inhabit them, instability follows. This suggests that wormholes are not designed for occupation. They are configurations of space-time that tolerate existence only in abstraction. The moment they are asked to carry substance, they collapse. Passage is not prevented by walls or barriers, but by the breakdown of the conditions that allow passage to be defined at all. The universe does not block the door, it removes the hallway. This reframes the entire question of traversal. Perhaps the mistake is imagining wormholes as places one can enter, rather than transitions that cannot host experience. Experience requires duration. It requires continuity. It requires a stable frame in which before and after make sense. Wormholes threaten all three simultaneously. Even if something were to cross, there may be no frame in which that crossing can be said to have occurred. Passage dissolves into geometry without narrative. From this perspective, wormholes look less like missed opportunities and more like structural limits. They reveal what space-time can momentarily resemble, not what it can sustain. The universe allows the equations to describe a door in space, but it never allows the story of walking through it to be written. The physics does not forbid the geometry, it forbids the experience, and that distinction matters deeply. There is a quiet elegance in this refusal. Reality does not need to enforce its limits loudly. It simply allows extreme possibilities to undo themselves when pushed beyond coherence. Wormholes are permitted as ideas, as shapes, as mathematical consequences, but not as environments. The universe seems content to let us glimpse what lies beyond ordinary structure, while ensuring that nothing remains there long enough to destabilize the whole. So the final answer to what would happen if you entered a wormhole may be simpler than expected. There may be no entry at all, no passage, no journey, only collapse before experience can form. The door in space exists, but it is a door without a threshold, without a crossing, without a story on the other side. And with that realization, the question of traversal comes to rest, not because it is solved, but because it no longer applies. Some doors are not meant to be opened. They exist to show us where the universe quietly ends its permission. Wormholes remain theoretical, not because science lacks imagination, but because reality demands restraint. Physics is filled with ideas that are mathematically elegant, yet physically unreachable, and wormholes sit among the most revealing of these. They persist in equations because the structure of space-time allows them as possibilities, but possibility alone is never enough. For something to move from theory into reality, it must survive contact with the full complexity of the universe. Wormholes consistently fail at this threshold. Every attempt to anchor them in physical conditions introduces instability, contradiction, or collapse. The universe acknowledges the idea, then quietly withdraws its support. One reason for this persistence in theory is that general relativity is remarkably permissive at the level of geometry. It allows space-time to bend in extreme ways without immediately judging whether those shapes can exist for long. The equations describe what space-time can times look like, not what it prefers to maintain. Wormholes emerge in this descriptive space as valid solutions, but solutions are not commitments. When dynamics, quantum effects, and interaction with matter are added, the picture changes. What looked coherent in isolation becomes untenable in context. Another reason wormholes remain theoretical is that they sit precisely at the intersection of our two deepest frameworks, relativity and quantum mechanics. Each framework tolerates wormholes in limited ways, but together they impose severe constraints. Relativity allows the geometry, quantum mechanics destabilizes it. The more one tries to satisfy both, the narrower the window becomes. Wormholes survive only in the gaps between theories, places where our understanding is incomplete. As those gaps close, the space for wormholes shrinks rather than expands. There is also a subtle selection effect at work. Physics tends to elevate structures that are robust, repeatable, and insensitive to small disturbances. Atoms, stars, galaxies, and even black holes meet these criteria. Wormholes do not. They require perfect conditions, exotic support, and isolation from noise. Anything that fragile is unlikely to appear naturally in a universe that is fundamentally turbulent. Reality favors what can endure without supervision. Wormholes demand too much care. Importantly, theory is not failure. Theory is exploration. Wormholes serve a crucial role by showing us where our models stretch thin, where assumptions about space, time, and causality begin to strain. They act as stress tests for physics, revealing hidden priorities in the structure of reality. By remaining theoretical, they teach without destabilizing. They allow us to see what would happen if the universe were more permissive, and why it is not. In this sense, wormholes are less like undiscovered objects and more like boundary markers. They define the edges of what space-time can momentarily resemble without unraveling. They tell us that geometry alone is not enough, that stability, causality, and coherence are non-negotiable. The universe may allow us to write the door into its equations, but it refuses to build the frame that would let the door stand. So wormholes remain where they belong, not as destinations, not as technologies, but as ideas that illuminate the structure of reality by their absence. They exist to remind us that not everything that can be imagined by mathematics is invited to persist in nature. And in that quiet refusal, the universe reveals its deepest preference, not for shortcuts, but for continuity. One of the most misunderstood aspects of theoretical physics is the belief that mathematics alone grants permission for reality to exist. In truth, mathematics is descriptive, not legislative. It tells us what times could times exist within a set of assumptions, not what the universe is obligated to realize. Wormholes persist because the equations of space-time allow them as internally consistent shapes. But consistency is not enough. The universe does not adopt every consistent structure. It selects, it filters, it allows only those configurations that can survive interaction, noise, and time. Wormholes pass the test of mathematics, but they fail the test of endurance. This distinction becomes clearer when we look at how often physics has produced mathematically valid entities that never appeared in nature. Certain symmetries, particles, and dimensions can exist cleanly on paper, yet remain absent in observation. Wormholes belong to this category. They are not errors. They are possibilities that lack permission. The equations describe a door, but the universe never supplies the key conditions required to keep that door standing. Mathematics opens the imagination. Reality closes the loop. What denies that permission is not a single law, but a convergence of constraints. Gravity pulls inward. Quantum fluctuations destabilize delicate geometries. Energy conditions restrict how matter can behave. Causality resists rearrangement. Each of these factors alone might be negotiable. Together, they form a net that wormholes cannot slip through. Any attempt to satisfy one condition worsens another. The system never settles. The universe does not forbid wormholes explicitly. It makes them incompatible with everything else it values. There is also a temporal aspect to this refusal. Even if a wormhole configuration could exist for an instant, existence in physics is measured not by appearance, but by persistence. A phenomenon that flashes into being and vanishes before interaction leaves no trace, no consequence, no participation in reality. Wormholes may exist only in this evanescent sense, allowed as transient distortions, erased before they can matter. Without duration, they cannot be tested, used, or even meaningfully said to exist. Permission without persistence is indistinguishable from absence. This is why wormholes remain powerful as theoretical tools. They reveal the boundaries of our frameworks. They expose where geometry, quantum behavior, and causality collide. They show us that space-time is flexible, but not infinitely so. By pushing our theories into regimes where they nearly contradict themselves, wormholes help us identify what the universe protects most fiercely. They are not failures of imagination, but successes of constraint. In this role, wormholes act as mirrors. They reflect back the assumptions we take for granted about distance, sequence, and connection, and show us what happens when those assumptions are relaxed too far. The universe allows us to glimpse alternative structures, but only long enough to understand why they cannot last. Mathematics can describe worlds that reality refuses to inhabit. Wormholes live precisely in that gap. So the reason wormholes remain theoretical is not that science has stalled, but that the universe has spoken quietly through consistency. It has allowed the equations to wander to the edge, then stopped them from crossing into permanence. The door in space exists as an idea, not as a place. And in that distinction, we learn something essential. Reality is not obligated to fulfill every structure mathematics can imagine. It chooses only those that can remain whole. If wormholes exist even briefly, a natural question follows: why have we never seen a trace of them? Modern astronomy observes the universe with extraordinary precision. We detect gravitational waves from colliding black holes billions of light years away. We map subtle distortions in space-time caused by invisible matter. And yet, no observation has ever demanded the presence of a wormhole. This absence is not accidental. It is consistent with the idea that wormholes do not leave signatures robust enough to survive the noise of the universe. They fail not only to persist, but to announce themselves. To be observed, a phenomenon must interact. It must bend light, emit radiation, alter motion, or leave an imprint on space-time that lasts long enough to be measured. Wormholes, by their nature, struggle with all of these requirements. A transient geometry that collapses almost as soon as it forms does not have time to shape its surroundings in a stable way. Any signal it produces would be indistinguishable from ordinary fluctuations, lost among countless other disturbances. The universe is loud. Wormholes, if they appear at all, would be whispers. There is also the problem of scale. The conditions required to form a wormhole are extreme, likely confined to regions of space-time already dominated by violent processes near black holes, early cosmic epochs, or quantum-scale fluctuations. In such environments, separating a wormhole signature from background chaos would be nearly impossible. Even if a wormhole briefly altered geometry, the surrounding turbulence would erase its fingerprint almost immediately. Observation requires contrast. Wormholes offer none. Some have suggested that wormholes could masquerade as other phenomena: black holes, lensing anomalies, unexplained energy distributions. But each time such candidates are examined, ordinary explanations suffice. Black holes behave exactly as predicted. Gravitational lensing follows known patterns. The universe shows no need to invoke hidden doors in space to explain what we see. Absence here is not ignorance, it is sufficiency. Reality explains itself without wormholes. There is a deeper implication in this silence. Wormholes may be self-concealing by necessity. Any structure that threatened causality or coherence would need to collapse before it could influence its surroundings noticeably. Visibility itself becomes a liability. To be seen is to interact. To interact is to destabilize. Wormholes, if allowed at all, must remain invisible to remain harmless. The universe does not merely prevent their use, it prevents their detection. This makes wormholes fundamentally different from undiscovered objects. They are not waiting to be found with better instruments or deeper surveys. Their absence is not a gap in data, but a feature of consistency. The universe behaves as though it actively avoids leaving evidence of configurations that could undermine its order. Wormholes are not hidden behind distance or dust. They are hidden behind impermanence. So we never see them because seeing requires endurance, and endurance is precisely what wormholes lack. They vanish before they can matter. They collapse before they can communicate their existence. The door in space never stays open long enough to cast a shadow. And in that silence, the universe quietly confirms what theory has been suggesting all along. Some possibilities are allowed only on paper, never long enough to be written into the sky. At the end of this line of reasoning, wormholes settle into a very different role than the one imagination often assigns to them. They are not failed technologies, not missed opportunities waiting for a clever solution. They are boundaries. They mark the edge of what space-time can describe without becoming unstable, incoherent, or self-contradictory. In this sense, theory is not a promise of future discovery, but a map of limits. Wormholes exist on that map, not as destinations, but as warning signs, places where the equations still function, but reality quietly steps away. This reframes how we should interpret theoretical existence itself. When physics produces a structure that is mathematically consistent, yet physically unreachable, it is not revealing a secret door to be opened later. It is revealing a constraint. The theory is showing us how far its own assumptions can be stretched before they stop corresponding to anything that can persist. Wormholes are not unfinished facts. They are completed lessons. They tell us that geometry alone cannot override stability, that connection cannot come at the cost of coherence, and that not every elegant solution is meant to leave the page. There is a kind of humility embedded in this realization. The universe does not rush to realize every possibility that mathematics allows. It selects with restraint. It favors structures that can survive interaction, time, and noise. Wormholes demand too much isolation, too much precision, too much protection from disturbance. They ask the universe to pause its own restlessness, and the universe never does. Theory reveals the shape of the door. Reality refuses to build the walls around it. Seen this way, the absence of wormholes is not a failure of observation or imagination. It is an expression of consistency. The same laws that allow stars to burn steadily, galaxies to form, and time to flow smoothly also prevent shortcuts that would unravel those processes. Wormholes are excluded not by prohibition, but by incompatibility. They do not fit into a universe that values continuity over novelty and persistence over possibility. This also explains why wormholes continue to fascinate rather than disappear from physics. They occupy a productive tension. They sit at the edge of understanding, forcing us to clarify what we mean by existence, stability, and reality itself. They sharpen our theories by exposing where assumptions break down. In doing so, they perform a vital role without ever needing to be real in the ordinary sense. Wormholes are useful precisely because they remain theoretical. So the final position of wormholes is neither disappointment nor mystery. It is definition. They define the boundary between what space-time can momentarily resemble and what it can sustainably be. The door in space is not an invitation. It is a limit drawn in geometry. And by respecting that limit, the universe preserves the order that allows everything else to exist. With this, the theory comes to rest, not resolved into reality, but resolved into understanding. Wormholes remain where they belong, at the edge of possibility, reminding us that the deepest truths of physics are not always about what can happen, but about what must not. There is a reason wormholes feel so natural in imagination, even as they resist reality. The human mind is drawn to shortcuts. We experience distance as effort, time as waiting, separation as loss. A structure that promises immediate connection across vast space resonates deeply with how consciousness wishes the universe would behave. Wormholes speak directly to this desire. They offer not just travel, but relief from scale itself. In imagination, they erase the burden of distance and make the universe feel intimate again. Physics may hesitate, but the mind does not. Stories adopt wormholes easily because stories do not require stability. A narrative only needs internal consistency, not physical endurance. In fiction, a wormhole can open exactly when needed, remain open just long enough, and close without consequence. The constraints that crush wormholes in reality, quantum instability, energy conditions, causality, are optional in imagination. This freedom allows wormholes to become tools rather than problems. They serve plot, not coherence. And because the brain is wired to think in narratives, these imagined doors feel convincing even when physics says otherwise. There is also a psychological comfort in imagining that space itself is negotiable. The universe, when viewed honestly, is vast and indifferent. Wormholes soften that indifference. They suggest that separation is temporary, that everything is closer than it appears, that the cosmos might secretly be folded in our favor. This idea is emotionally powerful. It transforms the universe from an expanse to be endured into a structure that can be traversed with ease. Imagination embraces this transformation eagerly because it aligns with human longing rather than cosmic reality. Science fiction amplifies this effect by borrowing the authority of physics without inheriting its restraints. By grounding wormholes in equations and terminology, stories give emotional ideas a scientific aesthetic. The result feels plausible even when it is not sustainable. The mind confuses mathematical permission with physical allowance. Wormholes become symbols of advanced understanding rather than markers of limitation. The boundary between theory and fantasy blurs, not through deception, but through desire. What makes this especially persistent is that wormholes are not pure inventions. They are born from real equations. They carry the legitimacy of science while remaining inaccessible to experiment. This places them in a unique category, ideas that are too rigorous to dismiss and too unstable to realize. Imagination fills that gap naturally. Where reality withdraws, narrative steps in. Wormholes become the language through which we explore questions about connection, time, and possibility without needing answers that the universe refuses to give. In this way, wormholes find their true home not in space-time, but in the space between knowledge and longing. They allow us to ask what it would mean to cross boundaries that reality maintains. They let us imagine a universe that bends toward us instead of away. Physics does not need to make them real for them to be meaningful. Their power lies in what they reveal about us: our impatience with distance, our discomfort with limits, and our enduring hope that the universe might one day open a door it currently keeps closed. Wormholes begin to change character the moment science reaches its explanatory edge. Up to a point, physics describes them with precision equations, constraints, instabilities. But beyond that point, language shifts. Mathematics gives way to metaphor. The wormhole stops being a structure that could exist and becomes a symbol of what cannot. This transition is subtle and often unnoticed. The same equations that once grounded the idea now serve as a backdrop for meaning rather than mechanism. Science does not abandon rigor, it simply runs out of permission to continue. This is where wormholes take on a second life. They become metaphors for connection across impossibility, for bridges between separated states, for shortcuts that bypass suffering, waiting, or loss. The brain is exceptionally good at repurposing technical ideas into emotional symbols. Once the physical interpretation fails, the conceptual one intensifies. Wormholes stop asking times, "Can this exist?" Asterisk, and start asking times, "What would it mean if it did?" Asterisk. In this space, imagination does not contradict science. It extends it into territory science cannot inhabit. The authority of physics lends weight to these metaphors. Because wormholes emerge from real equations, they feel different from pure fantasy. They carry the gravity of legitimacy. This makes them powerful tools for thought, even when they cannot function as tools for travel. They allow us to contemplate non-locality, simultaneity, and the fragility of sequence without needing to resolve them physically. Wormholes become safe containers for dangerous ideas, paradox, reversal, collapse, held at arm's length by theory. There is also a deeper reason this metaphorical shift feels natural. Science itself relies on abstraction. Concepts like space-time, curvature, and fields are not directly experienced. They are models that help us navigate complexity. Wormholes simply push abstraction further than reality allows. When the model breaks, the mind does not discard it, it reframes it. What cannot be realized becomes instructive. What cannot be built becomes meaningful. The failure of wormholes to exist physically enhances their value as conceptual probes. This process blurs the boundary between understanding and storytelling, not because science becomes fiction, but because both attempt to make sense of the unknown. Wormholes occupy a liminal space where explanation ends and interpretation begins. They are no longer predictions, but reflections, mirrors held up to our assumptions about space, time, and limitation. The universe refuses to host them, but the mind insists on exploring them. In that insistence, meaning emerges. So when wormholes live on after physics has stepped back, they do so as metaphors anchored in rigor. They remind us that not all scientific ideas are meant to be realized. Some exist to show us where our intuitions fail and where our desires project themselves onto the cosmos. The door in space remains closed, but the idea of the door reshapes how we think about separation, distance, and possibility. And in that reshaping, wormholes fulfill a role that reality itself never needed them to play. There is a quiet inevitability to the way wormholes end up framed as doors rather than destinations. Doors imply transition, possibility, and passage, but they also imply boundaries, places where movement is considered but not guaranteed. The universe seems comfortable allowing us to imagine the door, to define its shape mathematically, to describe its hinges in the language of geometry. What it resists is the act of crossing. This resistance does not feel hostile. It feels deliberate, structural, as though reality itself understands that some thresholds cannot be crossed without dissolving what lies on both sides. A wormhole as a door satisfies something deep in the human mind. It suggests that separation is an illusion, that vast distances are negotiable, that the universe might secretly be compact and connected. But the physics tells a different story. Each time the equations are followed honestly, the same conclusion appears. Opening the door undermines the very structure that allows doors, travelers, and destinations to exist. Passage requires continuity. Continuity requires order. Wormholes threaten both simultaneously. The universe does not dramatize this threat. It neutralizes it quietly by never allowing the door to function. This is why wormholes remain suspended in a permanent state of times, almost asterisk, almost allowed, almost stable, almost real. They live precisely at the threshold where permission ends. This threshold is not arbitrary. It marks the point where geometry begins to overpower causality, where connection begins to erase sequence. Beyond that point, experience itself becomes undefined. The universe appears to recognize this boundary instinctively. It allows the outline of the door to exist just long enough to be understood, then ensures it cannot be used. There is a subtle elegance in this restraint. Reality does not need to forbid exploration outright. It lets curiosity approach the edge, trace the contours, and learn. Wormholes act as lessons written into space-time, showing us how flexible the universe can be without losing coherence. They reveal the maximum strain space-time can endure before it must recover. In this sense, the closed door is not a denial, it is feedback. It tells us what kind of universe we inhabit, one that values persistence over possibility. As long as wormholes remain closed, the universe retains its narrative integrity. Events follow one another. Identity persists. Meaning accumulates. The door in space becomes a symbol not of failure, but of balance. A reminder that unlimited connection would come at the cost of structure itself. The universe does not owe us shortcuts. It offers continuity instead. And continuity is what makes everything else, memory, causality, existence, possible. So the wormhole remains what it was always destined to be. A doorway that defines a boundary rather than crossing it. It exists to show us where understanding gives way to humility. The equations can describe the door perfectly. The universe simply declines to step aside, and in that refusal, something profound is preserved, the quiet order that allows reality to remain whole. At the end of this exploration, a quiet conclusion settles in. Not every possibility exists to be realized. Some exist to define limits. Wormholes belong to this category. They appear where mathematics stretches far enough to glimpse alternative structures of reality, yet not far enough to carry those structures into persistence. The universe seems willing to let us imagine what could be, while carefully preventing what must not be. This is not failure or incompleteness, it is designed through restraint. Reality is not obligated to fulfill every consistent idea. It chooses coherence over indulgence. When physics allows a possibility but denies its endurance, it is revealing something about priority. Stability matters more than novelty. Continuity matters more than shortcuts. Wormholes threaten to collapse distance, sequence, and identity into a single act of connection. In doing so, they endanger the slow accumulation of cause and effect that gives the universe texture and meaning. The refusal to let them happen is not an act of limitation, but of preservation. The universe protects the conditions that allow anything to happen at all. This perspective reframes absence as intention rather than deficiency. Wormholes are not missing because we lack technology or imagination. They are missing because their realization would unravel the framework that supports stars, memory, evolution, and thought. A universe full of shortcuts would be a universe without story. Events would lose order. Consequences would lose relevance. Meaning would flatten. Reality would become simultaneous rather than sequential, and in that simultaneity, experience itself would dissolve. There is also a lesson here about knowledge. Science advances not only by discovering what exists, but by understanding why certain things cannot. Wormholes sharpen our understanding of space-time precisely because they fail. They illuminate the invisible constraints that hold reality together. By following them to their breaking point, we learn where physics stops negotiating. These limits are not disappointments, they are structure. They give shape to everything that does exist. In this light, wormholes fulfill their role completely without ever opening. They show us how flexible space-time can be without losing itself. They reveal the tension between connection and coherence. They teach humility, reminding us that the universe is not a playground for every conceivable geometry, but a system with deep preferences. The door in space exists not to be crossed, but to be contemplated. And so this chapter comes to rest. The imagination may continue to open the door, again and again, in stories and dreams. Physics, however, closes it gently, every time, for the same reason. Some possibilities are allowed to exist only as ideas, because ideas do not threaten the order that keeps reality whole. The universe lets us look but not step through. Even after physics has closed the door, the mind continues to stand in front of it. This persistence is not accidental. Human cognition is shaped by gaps, by distance, by delay, by separation. We are creatures who experience time as waiting and space as effort. Wormholes promise relief from both. They offer a universe where arrival does not require endurance, where separation collapses into immediacy. The brain, tuned for efficiency and resolution, gravitates toward this idea instinctively. Even when reason steps back, imagination steps forward. There is also a deeper cognitive pattern at work. The mind is uncomfortable with absolute limits. When confronted with boundaries that cannot be crossed, it does not simply accept them, it circles them. Wormholes sit precisely at such a boundary. They are close enough to feel real, grounded enough to feel legitimate, yet distant enough to remain unreachable. This combination makes them irresistible. The brain treats them not as closed questions, but as unfinished ones. The door remains psychologically open even when it is physically sealed. Wormholes also resonate with how consciousness experiences itself. Thought moves instantly. Memory collapses years into moments. Imagination ignores distance effortlessly. Internally, the mind already lives in a wormhole-like space where separation and sequence are flexible. The idea that the universe might mirror this internal freedom feels intuitive, even comforting. Wormholes project the structure of consciousness outward onto space-time, suggesting a cosmos that thinks the way we do. Physics rejects this projection, but the mind continues to offer it. There is comfort, too, in the idea that the universe hides shortcuts. A cosmos without hidden doors feels indifferent, even cold. A cosmos that secretly connects distant places feels intentional, almost kind. Wormholes soften the existential weight of scale. They suggest that isolation is not final, that distance is provisional, that connection is embedded deeper than it appears. The mind returns to this idea not because it is true, but because it is reassuring. Even scientific curiosity plays a role. Wormholes sit at the intersection of what we know and what we do not. They are born from our most successful theory of gravity, yet they resist integration into reality. This tension keeps them alive in discourse. Scientists revisit them not to prove they exist, but to understand why they fail. Each return sharpens our understanding of space-time's constraints. The door remains closed, but it continues to teach. So the mind returns again and again, not expecting the door to open, but needing to understand why it does not. Wormholes become a place where curiosity, desire, and humility meet. They remind us that some ideas endure not because they are achievable, but because they illuminate the shape of our limits. The door in space remains closed, but the act of standing before it continues to deepen our understanding of both the universe and ourselves. At a certain depth of understanding, it becomes clear that the door in space is not pointing outward at all. It is pointing inward. Wormholes persist in thought not because they reveal something hidden in the universe, but because they reveal something unresolved in us. They reflect our discomfort with separation, our impatience with time, our resistance to limits. The universe may not contain shortcuts, but the mind is built to search for them, and when it cannot find them in reality, it projects them into theory. This projection is subtle. It does not feel like fantasy. It feels like inquiry. Wormholes are framed as scientific possibilities, discussed in the language of equations and space-time geometry, yet they quietly carry emotional weight. They answer questions science never asked, but consciousness always has. Asterisk. Must distance always mean loss? Must time always mean waiting? Must separation always be final? Asterisk. The door in space appears where these questions gather, offering a shape to longing rather than a mechanism for travel. In this way, wormholes become mirrors. They show us the shape of our expectations about the universe. We want reality to behave like thought, instant, connected, reversible. But reality does not owe us psychological comfort. It evolves slowly, unfolds sequentially, and preserves order at the cost of immediacy. Wormholes dramatize this mismatch. They exist precisely where desire and structure collide. The door does not open because the universe does not share our priorities. There is a quiet humility in recognizing this. The refusal of wormholes to exist physically is not an insult to intelligence or imagination. It is a reminder that the universe is not designed around human convenience. The laws of physics emerged long before minds capable of wishing for shortcuts. They preserve coherence, not comfort. Wormholes fail not because we are insufficient, but because reality is consistent. This realization changes the role wormholes play in understanding. They are no longer problems to be solved or technologies to be developed. They become reference points, ways of measuring how far our intuitions drift from the structure of the cosmos. Each time the mind returns to the door and finds it closed, it learns something about itself. The desire for connection, immediacy, and reversal is exposed, examined, and gently set aside. So the door in space remains, not as a passage, but as a reflection. It shows us the difference between how we wish the universe to behave and how it actually does. In that reflection, something valuable emerges, not disappointment, but clarity. The universe does not hide shortcuts from us. It simply was never built with them in mind. And by accepting that, the mind begins to rest, no longer searching for doors that were never meant to open. At this stage, it becomes clear that the door in space survives not because physics allows it, but because the human mind needs it to exist somewhere, even if only in thought. Consciousness is built around continuity, yet it is painfully aware of discontinuity. We live inside distance, delay, separation, and irreversible time. Every experience confirms that what is lost remains lost, that what is far stays far, that what has passed cannot be revisited. Wormholes emerge as a counterweight to this reality. They function as a psychological release valve, an idea that momentarily relieves the pressure of finality. The mind returns to the door not to escape reality, but to soften it, to imagine that beneath the surface of an uncompromising universe there might exist a hidden mercy, an exception quietly written into the structure of space itself. This need intensifies precisely because modern science has revealed how vast and indifferent the universe truly is. The more accurately we measure distance, the more unbearable distance becomes. Light years replace journeys. Cosmic timescales replace lifetimes. The universe grows larger as the self feels smaller. Wormholes offer a symbolic correction to this imbalance. They suggest that scale is negotiable, that immensity might be folded, that the universe could secretly be closer than it appears. This idea does not arise from ignorance. It arises from comprehension pushed to emotional limits. The mind understands the vastness and rebels quietly against it. What makes the door so persistent is that it mirrors the internal structure of thought itself. Inside the mind, time collapses constantly. A memory from decades ago appears instantly. A future scenario is simulated in a heartbeat. Consciousness moves non-linearly, jumping across its own internal space-time without cost. Wormholes externalize this inner freedom, projecting it onto the cosmos. They represent a universe that behaves the way thought behaves. Physics resists this projection, but the mind continues to offer it because it feels intuitive, even necessary. There is also a deeper existential layer beneath this attraction. Wormholes promise not just connection, but repair. They imply that separation is not absolute, that endings might be provisional, that loss might be bypassed rather than endured. In this sense, the door in space becomes a quiet refusal to accept irreversibility. It is not about travel, it is about meaning. A universe with wormholes feels less cruel, less final, less rigid. The mind clings to this possibility not because it expects it to be real, but because it struggles with a universe that offers no exceptions. Yet this is precisely where the lesson sharpens. The persistence of the door reveals not a flaw in physics, but a tension between human psychology and cosmic structure. The universe does not adjust itself to relieve our discomfort. It preserves continuity, even when continuity hurts. Wormholes fail not because the equations are incomplete, but because reality does not bend to emotional necessity. The door remains closed, not out of indifference, but out of consistency. And in recognizing this, something subtle begins to shift. The mind no longer needs the door to open. It begins to understand why the door exists as an idea and not as a passage. Wormholes become a psychological artifact, a marker of where longing meets law. They teach us not how to escape distance, but how deeply we feel it. And as that understanding settles, the door in space loses some of its urgency. It remains present, but no longer demanding. The universe does not offer shortcuts. It offers endurance. And slowly, the mind learns to rest inside that truth. At the end of this inner return, something unexpected happens. The door in space begins to lose its urgency, not because it has been disproven, dismissed, or ridiculed, but because it has been understood. The mind no longer stands before it with expectation, it stands with recognition. Wormholes no longer feel like missed opportunities or secret promises withheld by the universe. They feel like ideas that have already done their work. The longing they once carried has been absorbed, examined, and softened. The door remains, but it no longer pulls. This loss of power comes from clarity. When the mind sees that wormholes are reflections rather than invitations, the emotional charge dissolves. The universe is no longer imagined as hiding shortcuts out of indifference or cruelty. It is understood as preserving coherence with quiet consistency. Distance, time, and separation are no longer enemies to be defeated by geometry. They are conditions of experience itself. The door loses its force because the mind stops asking it to fix what cannot be fixed. In this moment, the imagination does not shrink, it matures. It no longer needs to project mercy onto the cosmos in the form of hidden passages. It no longer needs to believe that everything painful must be bypassable. Wormholes recede from desire into understanding. They remain fascinating, elegant, and profound, but no longer necessary. The universe is accepted as it is, vast, slow, sequential, and unyielding in its order. And that acceptance brings a strange calm. What replaces the door is not disappointment, but depth. The mind begins to inhabit distance rather than resist it. Time is no longer an obstacle to be escaped, but a structure that gives meaning to change. Separation becomes the condition that allows connection to matter. Without distance, arrival would mean nothing. Without time, memory would dissolve. Without order, experience would lose shape. The door in space closes, and in that closure, the universe becomes legible again. This is the quiet resolution of the search, not an answer discovered, but a question released. Wormholes no longer function as promises or threats. They become symbols of a stage the mind has passed through, a necessary fiction that helped us confront the limits of reality and our response to them. The door taught us what we wanted. Its refusal taught us what the universe requires. And so the mind steps back, not away from wonder, but into a deeper one, a wonder that does not depend on shortcuts or exceptions, a wonder rooted in continuity, persistence, and the slow unfolding of cause into effect. The universe does not open every door we imagine. It does something quieter. It holds together. And in learning to rest within that holding, the need for doors fades, leaving behind a stillness that no passage could ever improve. When the door in space finally disappears from the center of attention, what remains is not emptiness, but something far quieter and far more enduring. The universe does not collapse into disappointment once the promise of shortcuts fades. Instead, it reveals its true structure, one that was always there, patiently holding together without needing to bend toward our wishes. Space stretches again. Time resumes its steady unfolding. Distance returns to its role not as a punishment, but as a condition. And within that condition, meaning becomes possible in a way no shortcut could ever provide. What remains is continuity, the slow, unbroken thread that allows existence to feel real rather than instantaneous. Without the door, the mind stops leaning forward. It no longer waits for exceptions hidden in geometry. Attention settles into what is actually present rather than what might be bypassed. This settling is not resignation, it is alignment. The universe does not promise immediacy, but it offers persistence. Stars burn steadily, galaxies evolve slowly. Causes lead to effects with unwavering patience. The absence of shortcuts becomes the reason anything can last. Without continuity, nothing could accumulate, nothing could deepen, nothing could be remembered. There is also a subtle shift in how wonder is experienced. When wormholes dominated imagination, wonder was focused on escape, on what lay beyond distance, beyond sequence, beyond constraint. Now wonder turns inward and outward simultaneously. It rests on the fact that something as vast as the universe remains coherent at all. That space-time holds together without tearing. That order survives expansion. That complexity emerges without collapsing into contradiction. This kind of wonder does not demand exceptions. It arises from endurance itself. What remains, too, is responsibility. In a universe without shortcuts, actions matter because they unfold in time. Choices matter because consequences cannot be erased or bypassed. Meaning depends on sequence. Relationships deepen because they cannot be jumped over. Loss hurts because it is final. But it is precisely this finality that gives weight to experience. A universe that allowed doors through everything would also flatten everything. Without distance, arrival would be meaningless. Without time, growth would be impossible. As the mind accepts this, it no longer searches for hidden passages in space-time. It begins to inhabit the present more fully. The need for escape dissolves into presence. The universe no longer feels like something to be outwitted, but something to be lived within. The door in space fades not as a loss, but as a completion. Its purpose was never to open. It was to teach us why opening it would undo what we are trying to protect. So what remains when the door is gone is not limitation, but structure, not confinement, but coherence. The universe stands revealed as a place where things happen slowly, irrevocably, and meaningfully, where time flows forward not to frustrate us, but to allow stories to exist at all. And in that realization, the mind finally rests, not because it has found a way out, but because it has understood why there never needed to be one. In a universe without shortcuts, movement regains its meaning. Distance is no longer something to be cheated, but something to be crossed, slowly and deliberately. Time is no longer an inconvenience, but the medium through which change becomes possible. When the fantasy of instant connection dissolves, what remains is a cosmos that asks for patience rather than cleverness. And patience, unlike speed, allows depth. Stars form over millions of years. Life evolves through countless iterations. Thought itself matures by moving forward step by step. A shortcut universe would erase this richness. The absence of wormholes protects it. Without hidden doors, the universe becomes honest. It does not pretend that everything can be reached immediately or repaired instantly. It allows separation to exist long enough for longing to matter, for effort to have value, for arrival to feel earned. In this honesty, there is a quiet dignity. The universe does not rush, it unfolds. And by unfolding slowly, it allows meaning to accumulate rather than evaporate. What takes time can be remembered. What is remembered can shape identity. What shapes identity gives existence weight. This structure also reshapes how we relate to uncertainty. Wormholes once suggested that the unknown might be bypassed, that mystery could be jumped over rather than lived through. Without them, mystery regains its rightful place, not as an obstacle, but as an atmosphere. The universe remains vast, partially unknowable, resistant to total comprehension. But this resistance is not cruelty. It is what keeps curiosity alive. A universe with all paths open would quickly become dull. A universe with limits invites exploration that never exhausts itself. There is a profound calm in recognizing that reality does not need to accommodate every desire to remain meaningful. The absence of shortcuts does not diminish wonder, it stabilizes it. Wonder becomes less frantic, less desperate to escape finitude. It slows down. It becomes contemplative rather than impatient. The mind no longer scans the cosmos for exits. It listens instead to the steady rhythm of expansion, to the long echoes of cause and effect, to the quiet persistence of structure. In this slower universe, presence becomes possible. Experience is no longer overshadowed by the idea that somewhere, something could have been skipped. Each moment stands on its own, unreplaceable and unrepeatable. Time flows forward, not as a barrier, but as a path that can only be walked, never folded. And walking, unlike jumping, allows awareness. It allows reflection. It allows rest. So, a universe without shortcuts is not a poorer universe. It is a universe that takes itself seriously. It does not scatter meaning across instant connections. It concentrates meaning along continuity. The door in space is gone, and in its absence, the universe becomes whole again, coherent, patient, and quietly sufficient, asking nothing more than to be inhabited as it is. As the idea of shortcuts finally dissolves, the mind begins to rest inside the flow it once resisted. There is no longer a need to escape distance or outpace time. The universe is experienced not as something to be overcome, but as something to be trusted. Continuity, once mistaken for limitation, reveals itself as support. It is the steady ground beneath experience, the reason thoughts connect, memories form, and identity persists. Without continuity, everything would fragment into isolated instants. With it, existence gains texture, direction, and quiet reliability. In this state, time loses its urgency. It no longer feels like something slipping away, but something carrying experience forward. Moments are no longer measured against what could have been skipped. They are allowed to unfold fully, one after another, without comparison. The universe does not rush, and neither does the mind. Cause follows effect gently. Change accumulates slowly. This slowness is not emptiness, it is depth. It allows awareness to settle instead of scatter. Space, too, softens. Distance is no longer an enemy. It becomes a form of breathing expansion and separation that gives shape to presence. Without distance, there would be no perspective. Without separation, there would be no approach, no arrival, no closeness that means anything at all. The absence of wormholes restores the meaning of nearness. What is close feels close because it was not instant. What is far remains far without being threatening. The universe holds everything in place without forcing collapse. As the mind accepts this structure, tension releases. There is no longer a need to search for hidden passages or secret mechanisms beneath reality. Nothing essential is missing. Nothing needs to be corrected. The universe is sufficient as it is. The door in space fades completely, not slammed shut, not denied, but simply no longer relevant. Attention drifts away from what might have been and settles into what continues to be. This settling has a physiological echo. Breathing slows, thought stretches. Awareness becomes less focused on destination and more attuned to presence. The mind aligns with the rhythm of the universe, steady, directional, irreversible, and calm. There is comfort in knowing that nothing is suddenly going to fold, reverse, or disappear. Stability replaces possibility, and stability, unlike possibility, allows rest. So in the quiet, left behind by the vanished door, something essential remains: trust in continuity. The universe does not need to offer shortcuts to be gentle. It offers order instead. And as the mind synchronizes with that order, the need for doors dissolves completely, leaving only the slow, reliable unfolding of existence, enough, steady, and finally at peace. And now, nothing more needs to be reached. The search has ended not with an answer, but with stillness. The universe does not reveal a final door, a hidden mechanism, or a last secret waiting behind space. Instead, it offers something far quieter and far more complete. It continues smoothly, patiently, without interruption. Time moves forward without asking to be escaped. Space holds its distances without apology, and within this steady unfolding, Everything that needs to exist already does. The mind no longer leans forward. It no longer scans for exits. It simply rests inside the rhythm that was always present. In this quiet, the universe feels less like a puzzle and more like a presence. There is no urgency left in understanding it fully. Understanding relaxes into acceptance. The slow flow of cause into effect becomes soothing rather than restrictive. Each moment arrives, stays briefly, and dissolves naturally into the next. Nothing is rushed. Nothing is skipped. Nothing is missing. The absence of shortcuts reveals that the journey was never meant to be shortened. It was meant to be inhabited. The door in space is no longer remembered as a loss. It fades as a completed thought. Its purpose was not to open, but to guide the mind to this exact realization that continuity is not a barrier, but a shelter. That time is not an enemy, but the medium through which meaning gently accumulates. That distance is not separation, but the space that allows closeness to feel real. The universe did not deny us anything essential. It protected what allows experience to remain whole. As this understanding settles, thought slows further. Ideas no longer compete for attention. Curiosity softens into calm awareness. The universe does not demand vigilance. It does not surprise violently. It unfolds. And unfolding is predictable enough to be trusted, yet rich enough to never become empty. The mind, sensing this reliability, releases its grip. Control is no longer necessary. Anticipation dissolves into presence. Breath follows this rhythm naturally, in and out, unforced. Awareness widens, then gently narrows, like a tide receding without resistance. There is nothing left to solve, nothing left to cross, no threshold waiting to be stepped through. The door in space is gone, and in its place is something deeper, a sense that being here, now, moving forward one moment at a time, is enough. And so the universe continues exactly as it always has, quietly, reliably, without shortcuts, without interruption, holding everything together with patience rather than speed. The mind, finally aligned with this structure, lets go completely. Thought fades into background hum. Awareness drifts. Continuity carries everything forward without effort. Nothing more needs to happen. Nothing more needs to be imagined. You can rest now. The universe will keep going,